So for number 28, the relationship between 7 to the x, which is this black graph, and log base 7 of x, is they're inverses of each other. So I can see that from the graph because they're reflected over the line y equals x. So now for graphing logarithmic functions, instead of having a horizontal asymptote that an exponential has, we're going to have a vertical asymptote. And that's going to happen at whatever value makes whatever you're logging 0. So what makes x 0? Well, 0. So my vertical asymptote is at x equals 0. I can think of this in exponential form as long as I move the 2 to the other side. So I'm going to rewrite this, and actually, if you like the Roman numeral 9 rule, I'm going to move the y plus 2 to this side, and the equals sign as well. So now that I just switched the sides of my equation, I can use the Roman numeral 9 rule because the log is on the left. So 10 to the y plus 2 equals x. So to find a good point to graph, I'm going to make y -2. We're not used to choosing a y, but when I make y -2, I get 10 to the 0, so 1 is x. So the point 1, -2. And my graph goes this way. So I have my asymptote as x equals 0. My domain is that x needs to be greater than 0. My range is all reals, and the function is increasing. Now for b, my asymptote is going to happen when x minus 2 equals 0, and that's at x equals 2. If I want to change this to exponential form to find a nice point to graph, I'm going to choose y as 0, so that makes this 1, so x will be 3. So over 3, up 0. Graph goes this way and approaches our asymptote on the left. So the domain is x is greater than 2, range is all reals, and again this graph is increasing.